Okay, I have a piece of paper. I cut squares out of the corners. I'm folding it up to make a box. Here's my box. And the question is, how big should I cut the square so I have maximum air volume here? Do I want a really shallow box that has a bigger base, or do I want a smaller base and a deeper box? So, here's the question. I have a sheet of paper that is 11 by 8.5. I want to maximize the volume of the box formed by cutting squares out of the edges and folding up the sides. So I draw a picture over here. Let me take the answer off for just a minute. Okay. I label it. It's 11 by 8.5, and I'm cutting out squares of side S. The volume of a box is length times width times height. If I'm folding it up, I know that my height is S. Well, if I'm cutting two squares out, my width becomes, oh, you can't see that, my width becomes 8.5 minus 2S. My length is 11 minus 2S. So now my volume is length times width times height. Multiplying that all out gives me 4S cubed minus 39S squared plus 93.5S. So what are my constraints? Well, I have to cut out more than 0 or I'll have no volume. And I can't cut out any more than 4.25 because this length is only 8.5. So, take the derivative, 12S squared minus 78S plus 93.5. Use the quadratic formula. I get two values, 4.9, 1.59. 4.9 is too big. I'm only allowed to have a square maximum of 4.25. So I'm going to check the volume at 1.59. So, if again, checking my endpoints, if I plug in 0 to this to get the limit, I have no volume. If I cut out no square, I have no height. If I plug in 4.25, I also get 0 because I have no width. So my maximum volume is occurring when S equals 1.59. So I know now that these squares should be 1.59 inches. And if I'm remembering correctly, when I plug that in, that gives me 66 point, I can't remember what, cubic inches for my volume. So again, what did I do? I drew a picture. I labeled it. I found the constraints. I wrote my function. I took the derivative. I checked the critical points and the endpoints.